Hey guys, it's Kendra, and this is not supposed to be shown yet. Okay, today we're going to be working on rhombuses and their properties in order to apply them to solve problems relating to rhombuses. Mainly include finding the lengths of sides and finding angles. So first things first, we're going to be identifying all the properties, which include all sides equal, opposite angles equal, opposite sides parallel, actually, I'm going to get rid of some of those. We're going to be focusing on the main ones we're going over today and going to be using to solve. And adjacent angles. Or we don't even need that out here. Most of the properties are, parallelogram properties, so I'm not going to write them. I'm just going to write the ones that we're going over today and the very unique kind of characteristics. So we know that all sides are equal. We know that opposite angles are equal. And we know that diagonals are perpendicular and bisect one another. So we're actually going to be writing this down. So we can see here that all sides are equal, demonstrated by this one line, symbolizing that they are all equal. Opposite angles are equal as well. The measure of angle A is also equal to measure of angle C. And measure of angle B is also equal to measure of angle D. The diagonals are perpendicular and bisect one another, as we can see. Line segment or diagonal AC bisects angle / diagonal BD, and it bisects it, or it intersects it, since they are perpendicular, and they bisect another, in which they divide the other line segment, the one that they are intersecting, evenly, distributing it evenly in a way. So given that this is true, and these are the properties, we are going to apply them now in 3 examples. Really straightforward, but very useful at the same time. So first one's first. Taking into account the property that all sides are equal, we can simply set these 2 side lengths, such as WT and TU. If we set them equal to each other, which is proved by this property, we can simply solve for y using algebra. This unit in geometry is basically using logical reasoning, which I at times do not like over, just simple math, such as just algebra, or kind of just understanding what to do rather than finding my own way of solving, because it can get a little chaotic in a way. But yeah, simply using algebra to solve, which you guys should understand by now, I guess. Most likely. Okay, yeah. At this point, yeah, just use your algebraic method of solving, and you will get y equals 1. So we know that y equals 1, and if we were to solve, or if we were to want to know what tu equals, we'd simply input this amount for y and solve, which will give us 39, which, using this property once again, I will circle it in blue. According to this property once again, if this side length equals 39, this side length will also equal 39. This will also equal 39. This will also equal 39. And we can even double check that by saying, oh, 2 times 1 plus 37, which also gives us 39. That's how we can double check our answer here. And the second example coming around is a little bit big of a jump. It is just all the same as important. And I think even more so important, because that property is fairly easy to recognize and understand and, apply, rather than just really needing that reasoning. This truly makes you need to find out why, how, when, where, what. So UTS. So UTSV, rhombus UTSV, we know that the measure of angle TSW, excuse me. 32, okay. Make sure everything's there. Yes. Minus 2y. We're trying to find the value of x, which we don't know. So simply giving this information, and that is a rhombus, we can apply what we already know. The perpendicular intersection perpendicular intersection of diagonals. Perpendicular intersection of diagonals equals 90 degrees. So we know that this equals 90 degrees, we know this equals 90 degrees, we know that equals 90 degrees, we know that equals 90 degrees. And in this case, here, just leaving that there. Yeah, that should be good enough. Yes. Okay. Given that that is 90 degrees, we can simply apply this logic. 32 degrees plus 90 degrees plus x, just in place for whatever, or excuse me, it actually is 2y, equals 180, because we know that this is a triangle which adds up to 180. We can simply say, okay, using the algebraic reasoning and just solving, we can simply solve for y. So given that this is 122, subtract 122, 2y equals 58, by 2y equals 29 degrees. So we know that right here, this is 29 degrees, so this is 29. Or not 29, it's actually 58. But 29 times 2, it's actually 58 degrees. So we know that y equals 29 degrees. But yeah, that equals 58 right here, which would also be the same as saying over here, up here is 29 degrees. Because opposite angles are congruent. Just to make that connection for you. And if we were to solve for, if we knew that the measure of TSW was equal to 29, we could also apply the same reasoning to SW or SVW, solving for V. If we were given some kind of expression to represent it, we could simply just apply it to the same form and solve. So yeah, Hopefully you understood that. Oh no, I erased the smiley face. That's okay. And in our final example here, it's more of just like a little reflection and really applying all that we have learned in this little lesson. So rhombus EFDC gives us only so much information. It is asking us how we know that this is a rhombus, if we can even tell at all. And truly, just given this information, we can't. Because we all don't, we don't know the angle. We don't know the other angle. We don't know the other side of this angle. So angle D, altogether we don't know because we don't know the other side of this angle. So 63 plus whatever equals measure of angle D, but we don't know what it is. So we can't confirm that this is a rhombus yet. But if it were given that, showing that these two are equal, if it showed that measure of angle E is equal to measure of angle C, we can confirm that this is indeed a rhombus because we can tell that this pattern will repeat and is pursued, as rhombus properties show that opposite angles are congruent. It is simply confusing to think about what it is having, especially when it's giving you numerical numbers that you think might be important. But really, if you think about what it's missing, it is a lot easier to understand these kind of cases. When it's asking you if this can be, if this is a rhombus, or how it would be deemed a rhombus, you would need to explain how the properties play a significant role in identifying whether or not it is a rhombus or not. And yeah, just if you're able to identify one pattern within it, it's most likely that it will repeat itself, especially because following rhombus properties, adjacency, if they're opposites, or if they're parallels, there is some correlation in relation there to where they will be congruent. So once again, opposite angles congruent, all sides equal, and last but not least, I can remember, the diagonal thing, I'm just going to write diagonals. We'll also say 90-degree angle with intersection. There was another thing. Angle, there, you said that. No, that's it. Okay. And that is what we find important here today. Simply applying this logic and reasoning and algebra to rhombuses and or even just like normal parallelograms or quadrilaterals, whatever you want to say, whatever you want to use for shapes. This is really key, basic, like fundamental information. It's basically your foundation in a way. If you understand the parallelogram properties, you are most likely going to do well with rhombuses, simply because rhombuses are parallelograms. It's just the few unique characteristics of each shape that really determine whether or not it is different from just like a simple parallelogram versus what type of parallelogram it is. It's generalized, but you know, the specific characteristics of it that are unique to the type are key to kind of understanding and applying them to solve problems related to them. So yeah, thank you guys. I hope this helped, and have a good day. Do well on your geometry tests.